Welcome to the second Axiom Design Center training video. In this case, we'll be going through a demonstration of how to actually use the interface to create a hypothetical design. For this training example, what we're going to be using is we're going to pretend that we're interested in creating an array to study cancer in a GWAS setting. So we have basically four different marker groups that we can think about identifying. The first is we're interested in getting all the non-synonymous markers in cancer-related genes. Second, we want to ensure that we get all the rare markers in cancer in the Caucasian population that are associated with these cancer genes. Third, we want overall coverage of the cancer genes. Four, we're interested in ensuring that we have the ability to perform an imputation with the Illumina 1M duo array. And the fifth requirement for this array is that it's a single peg array, which means that we're limited to approximately 650,000 total markers. So when you're thinking about your design and you look at this, is there a way you could identify a single target set or a single class of SNPs that you're interested in? And does that have a single selection rule associated with it? Or are you going to need to do more than one marker group? Simply by looking at this, we can see that we have at least two different target sets of markers that we're interested in. The first are the cancer-related ones, and then we got some separate filtering associated with those. And then we have the third, another set of genes, which is around the 1M dual. So minimally in this case, we're going to be looking at least two marker groups, and I can tell already that we're probably going to have four. So let's go to the Axiom Design Center site and see how we'll go about building this array. So after logging into the Axiom Design Center, if you log in for the very first time, a project will be created for you by default, and this is the project page or the project screen that you'll be taken to. At the top, we have the standard Affymetrix banner. On the left here, you can see the area that allows some navigation between projects, so your list of projects, the list of all the files you've uploaded, and a link to the help if you want to know more about how to do something on the Design Center. Here is the actual first project. It comes by default. You can see that it's named, in this case it's username, which that'll be where your username is. So let's navigate to that. If you want to make an additional project, you use the plus project button over here. So if you click on the name, it'll take you to the project. Now, having a project with your individual username is not particularly useful, but we have the ability to change the name here. So again, you can see the navigation stays the same, but now you can see we're in this particular project, which is called username. We'll click on edit so we can change the name of that to answer project. And if you want, you can choose to add a project summary here that will describe, what was specific about this project and what's going on with it. So if we look a little bit further down, now here we can see that we're in design attempt 1. A design attempt is basically the effort at what you think will be a complete array. You can have more than one design attempts associated with a project because it's likely you won't get it exactly right the first time and you want to make tweaks to it. So this is how you add additional design attempts or different tries at it. Navigating between the design attempts can be done down here. On the right side over here gives you the status of the project. New means that it hasn't been submitted to Affymetrix. Pending means that it's been submitted to Affymetrix, it's being processed, and then when the results are ready, it'll change to returned. Once one is done with the returned, you like it, you want to order that design, you will make it be finalized. Those are the statuses that we have. Here's how we submit it to Affymetrix for evaluation. So here's our design attempt. We can see that we don't have a marker group, so we'll click the plus marker group and create our first marker group for the project. So as you remember from the first video, the introduction training video, marker groups are basically a combination of two things. The identification of target sets of SNPs, or SNPs of interest, those you want to get your genetic information for, and a selection rule, which goes through how you're going to get the genetic information for those SNPs of interest. As we said, there's a couple of different ways that you can go about identifying the SNPs of interest. In this case, for this hypothetical design, we're interested in cancer-related genes. So that means that we'll probably have a file associated with cancer-related genes. To add a file, we click the plus file button here, and it brings us to the Add Files dialog. Now there's two options. If you have your own list of cancer genes, you would go to the Upload file, choose the file, browse to the location of it, and hit enter a summary if you wish, and then hit Add, which will upload the file to the project. and also to this design attempt in this marker group. In this case, we don't have a file that we want to use of our own. We can go to the Affymetrix files and see what is available there. Under the gene list, you can see we have a list of pre-computed gene lists for you to choose from. Some cardiovascular, immune and inflammation, the ADME list, and here we have a list of cancer genes based off of the Sanger Center cancer gene census. So we'll click that, and then we'll select Add to add this to our first marker group. So now we have marker group 1. We know that we're interested in the cancer genes. So the next piece about that is we were interested in specifically in the non-synonymous ones and the ones with a low minor allele frequency. So we can go to the filter section, and we will browse for adding the filter for non-synonymous markers. Now what's important to know is that if you try and add multiple filters within the same group, they will be combined with an AND, which means that if we added at this time the low minor allele frequency also, that means we would be searching for non-synonymous markers with a low minor allele frequency in Caucasian, which isn't what we want. We want all non-synonymous markers, and we want all markers with low minor allele frequency in Caucasian. So this indicates right away that we're going to need to make a second marker group for ourselves. But we'll finish creating the first one, and then I'll go through how to create the second marker group. So we've identified the genes that we're interested in. We're interested in a specific set of markers associated with them, the non-synonymous ones. And then we need to select the selection method for these. Because these are very important to us, these are most important SNPs, and we want to get coverage of them all, we want to look at the selection method, and we have direct selection selected. That means that if it was found to be validated in the Axiom genomic, if it works with the Axiom assay, that it will go on the array. If it's not validated, it won't. That means we have a set of taggable markers that if you pick direct selection will not be on the array. So what would be a better choice in this case is the best tag. So that for all the validated markers within the cancer genes, they will go on the array that are non-synonymous. And then also for the non-synonymous that are in there that weren't validated, the best tag from the Caucasian population will put on the array as a proxy for it. So we'll select best tag for that. Because we're interested in Caucasian, we check and make sure that the population here is Caucasian. If we're interested in either ASI or YRI, you would click the Edit button and be able to change that. So this is our first marker group, looking at the non-synonymous markers in cancer-related genes. Okay, so now we need to create the second marker group to look at the low minor allele frequency genes, or the markers in low minor allele frequency in the cancer-related genes. So there's two ways you can go about doing this. The first is you could click the plus marker group, which will create an empty marker group, and then you can go about adding the file again and then adding the filter. Or you can take this cool little shortcut, which is copy. So this will copy the exact version of this marker group. If you have multiple design attempts, it could copy it into a different design attempt if you want. But in this case, we only have one. And so if we open up marker group 2, we'll see now that the cancer gene list is already there, so we don't have to go through the effort of adding it. The non-synonymous markers are there. We are not interested in those, so we're going to remove that filter. We're going to click the plus filter button here so that we can again add our filter by markers by minor allele frequency, or MAF. So we'll click on that. And now we have a filter that shows up and says it's going to filter by minor allele frequency in Caucasian, and it's going to filter by default for all markers with a minor allele frequency. Since we're only interested in those with a low minor allele frequency, we'll click the Edit button, go in and change this from 0.5 to 0.05 and save it. So now we will be returning, in this case, all the markers that are within the cancer gene list that have a minor allele frequency in Caucasian between 0 and 0.5. Okay, so now again, the selection method we need to choose with this. Again, because these are the most important markers to us, I recommend in this case that we again stick with the best tag to ensure we get all those markers, and those that weren't validated, we get a proxy for them. Okay, so we've got two marker groups. Now the third set of SNPs that we were interested in, or markers that we expressed an interest in this hypothetical design, was all of markers associated with the cancer genes. So let's go ahead and create yet a third copy of this marker group. Open it up. Again, we have the cancer genes. Now in this case, we don't want to filter based on any specific criteria of the markers themselves, so delete that filter. And now we need to choose a SNP selection method. Well, we've got the most important ones covered for us already by having selected the best tag for the low minor allele frequencies and the non-synonymous ones, but we want to get general coverage of the rest. Because we're right now a little concerned about space on the array, and we don't absolutely care about every one of these single SNPs, I would suggest that in this case what we'll do is we'll change the best tag to greedy tag, which means the object of the greedy tag is to select the fewest number of validated SNPs as possible to cover the most number of markers. So this is sort of a space-saving device. So you get as much genetic information as possible, but you don't use up as much real estate on the array. So we've selected greedy tag, again confirming the population is CEU, and having the ability to set the R-squared for what we're interested in. So now we've got the cancer genes covered from our hypothetical design requirements. Now the fourth set of SNPs that we were interested in is ability to support imputation with the Illumina 1M array. So we'll add another marker group in this case. We'll open up. We'll go to the File menu. We'll go to the Affymetrix provided files, to our SNP list, and you can see here we have a list of markers that overlap with various arrays. For example, here we have the Pan-African array set. You can scroll down. We have the 500K, SNP5, so some historic Affy arrays. And if we get down here a little farther, we can see we have the Axiom overlap with the human 1M dual array. So let's select that and choose to add it to the array, or to this array design. So here, now we've got that. We're not interested in doing any filtering on those markers based on their relationship to transcripts or genetic information. And so then the next step is to actually select the selection method. Since the array, we're trying to limit ourselves to 650,000 SNPs. 1M is close, is up towards 1 million SNPs, so we clearly can't get that all on one array. So we're going to go with the greedy tag again to select the fewest number of markers to cover those as possible. Okay, so we have 4 marker groups that are defined. The next step in the process is to submit this to Affymetrix. You can either review it by going down all the marker groups, but I prefer to just click the Submit button, which brings up this nice summary report of the overall design. So we can see up here that we have green check marks, so we have all the appropriate files and they're in good formats. The filters are selected, and we have selection methods checked for everything. Here is a summary of marker group 1. We can see it's the cancer gene list, non-synonymous with best tag. We can confirm that marker group 2 is again the cancer gene list. We're looking for minor allele frequency, markers with minor allele frequency between 0 and 0.5 in Caucasian, and again best tag. Marker group 3, cancer genes, greedy tag, and marker group 4 is the 1M dual and the greedy tag. So we can see that our marker group summaries are all correct. At the bottom we get a choice of what population we would like to use or to have used during the generation of the reports. Because this is a design attempt to assay markers in Caucasian, we'll select the CEU, and then we'll leave it at a default of 0.8. We'll click the Submit button, and this will send the design attempt off to Affymetrix for processing. At this point, you'll get an email associated with the email that was used to register this project, and it'll tell you that a design attempt has been submitted. And then when the results are available, you'll get an email back from Bioinformatics Services at Affymetrix that says this project has been updated, and then you should come back here and open up the project and see your results. When you return to the Design Center, what you'll notice is the status of the Design Center as indicated by the status bar will have changed from pending to returned. This means that there are new results available for you. If you scroll down, you'll be able to see that there is now a results section which contains 2 different sets of files. There are the PDF reports and the bed files. The bed files zip also includes, in addition to the bed files, a missing.txt file. The missing.txt file contains the list of all the IDs in the input files that were not recognized by the system. So if you had a particular RSID that we didn't recognize, it'll be included in the files there. The PDF files contains the PDF reports. In both cases, you can simply click the download button in order to start the download of the files to your desktop. The PDF reports are available at 2 different levels. The first level is at the level of the design attempt, and the second is at the level of each individual marker group. And if you open the marker group, you can see that there is a result now for PDF here. This contains the detailed information at the marker group level, and the design attempt one is at the design attempt level. So let's open one of the PDF reports and see what they look like quickly. So here we have the PDF report at the design level for the cancer project. At the top contains the summary information, including what the report population was and the threshold, and then what the version of the data sources that underlie the version of the database that you're using. If you scroll down to page 2, here you can actually see the summary of the design attempt itself. At the top, we have a summary of what the target markers are, or the SNPs that we are interested in. The middle includes a summary of what the markers were and the breakdown for the markers that were actually selected to go onto the array, and then a detail of the number of markers selected for each marker group is shown at the bottom. So overall, we've expressed interest in 1.1 million markers with our 4 marker groups for this design. One thing to note is that in blue or highlighted are 935,784 markers. These are markers that have been shown to be polymorphic in CEU. This number is important because when we do our coverage calculations, we have to have genotype information, and the markers have to be polymorphic. If they aren't polymorphic, we can't calculate an R-squared value, so we can't tell you whether one marker is covered by another if it's not polymorphic in the population. This is important because, as you'll see later in the detailed summary, it can lead to some somewhat strange-looking results that aren't intuitive. So we have 1.1 million SNPs that we're interested in, and we've selected here, as you can see, 491,600 markers. So if we look at the detailed summary, I'll show you why this polymorphic and CEU thing is of interest. So marker group 1 was the effort to get all of the non-synonymous SNPs from the target set of cancer genes that we're interested in. So if you look at, you can see that we have identified, or the system has identified, 711 target SNPs. Then when we look at the next column, we can see that we selected 1,000 SNPs to cover those 700. That seems weird. Why do we have more selected than we do target? It goes back to, as I said before, the targets have to be polymorphic in CEU. So basically there are 400 markers that were selected that are not polymorphic in CEU, or are monomorphic in CEU. So we end up with more selected than the target set. Okay, so overall, for this design attempt, we've selected 491,000, which is definitely less than the 650,000 that would fit on one array. So this is good. It will all fit on the array. But there's space for another 150 or so thousand markers. So if you are interested, you could choose to add additional markers to this design attempt. So I'll return to the design attempt to show you the easy ways that we've facilitated this. So here we are back at our design attempt, and you can see that there, up here underneath the status, there's a button called Copy. If you select Copy, what will happen is a duplicate of this project will be made, but the one that was submitted and returned is not editable. The copy will now be editable. So here if we look in the marker group 4, this is still the original design attempt we were looking at, design attempt 1. If you look at here, there's no way to edit our functionality, right? So we've picked SNP set 1. I want to change this, for instance, to best tag, but I can't edit it. Now that I've made a copy, if we go to design attempt 2, our results section is missing because we don't have any results for this guy yet. And if we open it up, you can see now we can choose to add files, we can add filters, and we can change the marker group selection method. So there's 2 different ways you could choose to update or to add additional SNPs, in this case, to this design attempt. The first would be to change the greedy tag algorithm to something like best tag. Okay. That will probably, that will clearly increase the number of SNPs that you have. Because it's best tag, it will try to get 1 marker for each one from the Illumina array, and since that's 1 million, this is probably going to overshoot the array. So we'll probably go back and change this to just the direct selection to select the validated markers. That's one option. The other option is to add another marker group that contains additional criteria for another set of SNPs that you choose to add to the design attempt. So that basically brings us to the end of our walkthrough of the Design Center. I've shown you how to select marker groups, how to create marker groups, how to add files if you're interested in them, how to select filters for that, and to do the selection methods, and then access the reports and the set of report files that are available at the end of a design attempt. So before leaving you today, I'd like to just point out a couple of additional resources that are available on Affymetrix.com. First, there's the link to the actual Design Center itself. If you have a NetEffects account ID, you're all set up. You can start today, accept the license agreement, and move on. Otherwise, it's as easy as signing up for a NetEffects account, and then you'll be able to access the Design Center. We also have several other tutorials and manuals on the website, including a PDF document going into some more detail about the training example that I've used here. It also includes screenshots if you want to follow along that way to see how to use the Design Center. We have a quick start guide and a design guide, and of course there's the Design Center training video part 1 that is also available. So I'd like to thank you for your attention, and if you have any additional questions, feel free to contact Affymetrix at technical support at 188-DNA-CHIP or via email at support@affymetrix.com. Again, thank you for your attention.